Today we will multiply monomials using the properties of exponents, and we'll simplify expressions using the multiplication properties of exponents. So what is a monomial? A monomial is a number, a variable, or a product of a number and one or more variables. What this word means, mono is a prefix meaning one, and meal is a suffix meaning term. So this just means it's one term. And that one term can be one number, it can be one variable, or it can be a product of a number and variables. For example, it could be something like this. This would be a monomial because it's a product of a number and a variable. Or something like this. This could be a monomial because it's a product of two different variables. A constant is a monomial that is a real number. So a constant is just a number. In this example, the constant would be the 2. The letter can never be a constant, it's just a real number. So let's look at some examples here. We have to decide if this is a monomial or not. So 10, we would say yes, for sure. This is a monomial because it is a number. Now, f plus 24, we would say no. Try to look at your notes and think of why. It's not because this is what we call a sum. A product would be a yes, a sum is a no. How about C, h to the second power? Decide what you think it is now. It is yes. This is a monomial because it's a product of two variables, h times h. How about this, j? Is this a monomial? Think about what it is. This is a yes. J is a monomial because it's just a variable. How about E? A, B, C to the 8th all over 5. Think about what it is. This is a yes. Now I know some of you are kind of questioning, how could this be yes? If I rewrote this divide by 5 as multiplication of the reciprocal, so this is really 1/5 of this term, ABC to the 8th. Ah, yes, now this is a number, which is a fraction, multiplied by a variable, multiplied by another variable, by some more variables. So this is definitely a yes because it is a fraction multiplied. I know some of you saw that this was a quotient, a divide by 5, and you said, hey, that's not a product. But remember, when I have a fraction, that also looks like this division bar. How about MP over N? Think about what you think it is. This is a no. This is not a monomial because I'm dividing by a variable. So if I put 1 over n, that is still going to be dividing by n. So in this case, I'm going to say no, it is a quotient instead. So if this quotient is a number in your denominator, it's going to be a yes. If it's a variable in denominator, you're going to say no. So in your notes right now, work with example 1, which is finding out if it's a monomial or not. Example 2 is working with products of powers. So what I would recommend doing is multiplying the constants first, the numbers first. So 6 times 2 is 12. And then we work to multiply the variables. Now the rule is, if I have multiplication with the same base, like these two, what I can do is I can add those exponents. So I can just take 3 plus 7 to make it x to the power of 10. That is a shortcut. The reason this works is because I'm taking x to the 3rd times x to the 7th, and if you will look here, I could just count these and count 10. The shortcut with multiplication of the same base, the same variable, would be to add the exponents. So this would be the simplified version of A. How about B? I start first by multiplying the constants. It's 3 times 1, which is 3. And then I have P. If you look here, this is P to the power of 1. And I know some of you are saying, but hey, Mrs. A, there's not a 1 there. I know, but I have 1P. So this is P to the power of 1 times P to the power of 3. So we take 1 plus 3, so that's P to the 4th. And then I have T to the 3rd times T to the 4th. So that would be T to the 7th. If you just physically counted 1, 2, 3, 4, 5, 6, 7, I have 7 power of T right here. If you would just take it step by step, it's going to be a little bit easier. Constants first, then variables next. Go ahead and try the example in your notes. The next thing that we're going to do in example 3 is work with a power of a power. Now, the shortcut for a power of a power is multiplication. X to the 2nd cubed would be x to the power of 6. And here's some proof why. I'm taking x squared, 3 to the power of 3, So it's basically 3 times, x squared 3 times. So there's 1, 2, 3, 4, 5, 6 x's. 2 times 3 is 6. This case, I'm going to have 2 cubed squared, then to the power 4. So let's work with the smallest bracket first. 3 times 2, that would be 2 to the 6th, all of that to the power of 4. So this would be 2 to the power of 24. Now if you wanted to work that out on your calculator, since it's a base of 2, you could. This one is so big that it's okay to leave it as such. But if you get something like 2 to the power of 3, you could simplify that and say it's 8. 2 to the power of 6, you could do that. 2 to the power of 24. If this is too big to show on your calculator, you can leave it in this form. Why don't you try the example of your notes of a power to a power? Now, how about a power of a product? The formula for area of a circle is pi times radius squared, and the radius that we're given here is 2xy squared. So we're going to take pi times 2xy squared, all of this squared. When we work with taking a term to a power, we start with the constant. So 2 squared would be 4, x to the 1 to the power of 2 would be x squared, and y squared squared would be y to the 4th. And that's just using the multiplication because these are powers of a power. Then I'm going to multiply that by pi. And we could actually just leave pi alone. So I would say a for area is equal to 4 x squared y to the 4th pi, and we don't know what the units are, so we'd say units squared. So I'll give you a geometry example to do in your notes that you can try. Now the last thing that we're going to talk about is when we put everything together. So this is going to have a little bit of everything in it. As you could look here, I have 3xy to the 4th, all of this squared. So I'm going to work to simplify that first. And then over here, I have this negative 2y squared, all of this cubed off to the side. We'll end up putting this all together. So we start with the constant, 3 squared, 9. X to the 1 squared, that's x squared. Y to the 4th squared, that's y to the 8th. See if you have any questions on how I simplified that. Now up here, we're going to start with the bracket. So it's negative 2 squared, that would be positive 4 because we're taking negative 2 times negative 2. Y to the power of 2 is y squared, and all of this we are going to cube. So we do 4 cubed, that's 4 times 4 times 4, so that's 64. Y squared cubed would be y to the 6th. Now we're going to put them together because you see this is all multiplied together. So we start with the constants. I'm going to go ahead and write it out right here so you can see what I'm doing. So I start with the constants, 9 times 64. I'm going to do that on my calculator real quick because I can't do that in my head. So 9 times 64. $576. This does not have an x term, so I just write the x squared because it's not being multiplied by anything. Now we both have y's here, so we're going to say y to the power of, remember this is multiplication, so I have 8 here, 6 more here. So we're adding these powers because multiplication means you add the powers. So 8 plus 6 is 14. So this is the final answer. This is how we get from here to here. So I'll give you a more challenging example to try for example 5. All right, we're good.